Okay, we're ready for the 7A worksheet that goes along with the Math 4 course. We're going to be looking at 4 different data sets. First one is going to involve earthquakes. And the directive here is to try and figure out a good statistical question that you could ask that isn't already being asked, but some of these already have some questions. I'm looking at what they are asking you to do. Occupational data, the graph dragging a job title. I'm not sure. I don't think there's a way for me to see what's down at the bottom. They do not appear to be asking any particular questions. However, when I look at this graph over here, they are asking about a professor's salary. Well, I guess that's the whole thing, is about their salaries. This is the professor category, and then they've got the associates, and then they've got the assistant professors, and so on. So they're asking one question. So I would say, let's not ask this category. I want you to find something else. So when we look at the broader, well, I guess there's not that many categories to look at. You've got all of these universities that are masters and baccalaureates and doctors. So looking at this, one statistical question would be instructor, because not everybody's going to get their master's and doctorate, that sort of thing. Now, an associate and assistant professor. Wonder what the difference is between the two. I know there is one, and it may be that the directions here tell us what is the difference between the two. Although I don't see it. My directive was to find something that they didn't do. So let's see what happens when we do a graph. Let's shrink this down a bit. And let's go this route. All right, so with the graph, that is all of them. We're going to look at what is it that an associate professor, and they're showing the range from 26 to 97,000. We're going to drop the associate professors down here. That's a lot, and that's quite a pile. Now let's bring in the categories, which separates the ones that are teaching at 2-year versus baccalaureate versus master's versus doctoral institutions. And so I guess a valid question here would be, what is your typical salary for one of these guys? So let's start with the box plot. See what happens with the box plot. And it shows you where your middles are. What your mean is going to be, 49.5 and 55 for 2-year and baccalaureate institutions. But if you get to the master's level, now it's up to 56, and now it's up to 66 at a doctoral institution. I guess that, in a sense, that answers our question. Let's see if mean and standard deviation give us any further information. The spread seems to be about the same in all cases. it shows that there is a bit of a skew here and here, that you've got somebody making ridiculously more than everybody else, but you almost might consider them outliers, considering the data set. So we'll just stick with the box plot, and we'll make that our screen grab, and then we'll go back to the notes, and we'll paste it here, and then a good statistical question would be, what does your typical associate professor make between the 4 levels of universities? And you could answer specifically that they make about 50,000 in the lower levels, but they make 56 and 66 in the upper levels. And you've largely answered the question just by separating the data and showing what their median salary is going to be at each level. So, all right, that's number 1. Well, no, actually, faculty. Did I grab the right one? No, faculty was which one? Number 3. I apologize for taking them out of order. This is number 3. All 4 ask for the same thing. Create a good statistical question, and then create a graphical display that supports your answer to the question. So, all right, that was number 3. Now let's see if I can take them in order this time. We're looking for the earthquakes. So I'm guessing that is going to be the earthquakes. All right. Data set explores 491 earthquakes took place in California in 2012. I don't need that anymore. This is a map of the earthquakes, which can be helpful. Because they've got latitude and longitude, so you know exactly where they happen. It does have a tendency to show you patterns and trends, where the fault lines are, and of course the majority of them happened, like from Los Angeles south. There's a huge cluster of them there. I'm not sure that that's going to be that helpful, so we'll come back to that. Now, this was one where they did a study of the depths of the earthquakes. So that's a question that we don't want to address. All right. Like I said, you don't do the ones that everybody else did. So let's see. Apparently, this is the only data that you've got: magnitude, latitude, longitude, depth, location, local time, UTC time. So since we've already done depth, maybe magnitude would be a good one to study. So let's see. Let's change this to case card view, and we're going to do a graph, and we want to do magnitude. I'm going to drop magnitude down here, and that shows us the magnitude of it. And of course, they're all in tenths. 1, 1.1, 1.2, and so on. So I think I'm going to. No, I don't want to do a bar for each point because it's going to do that, and I don't want it to do that. So let's go back to points. And maybe if I stretch it further this way, it'll be a little bit more reasonable. Now, I wonder if I do count. No, it's just going to do all 491 counted together. Let's do a box plot. And these things are, well, I thought they were movable. Well, that's interesting. You can click on a different part of the box, and it highlights an entire group of values. The upper, which represents 1/4 of all of the data. And this represents 1/4 of all the data. And then this represents half of it right there. That's the middle half. So, most of your earthquakes, and it might be even more suggestible to look at median and standard deviation, and leave out the box plot for a minute, because that seems to cover more of this. There's, when you talk about what is outside of your one standard deviation, plus or minus one deviation, this really represents the middle. Now, where was median? Median was over here at 1.4, but the mean is 1.575. And of course, part of that is that you've got some outliers up here that are dragging the mean to the right. So here you've got to wrestle with the idea of, do I want the box plot to represent my middle, or do I want the standard deviation to represent my middle? I don't know. And either one, there's an argument either way. There really is. I think I'm going to lean toward doing the box plot and going that way, where it's literally cutting it into quarters. All right, there's that quarter. There's that quarter. Yeah, it does. Is it counting the same line twice? Yes, it is counting the same line twice. That's interesting. When I light up the left part of the box, that should be only 25% of it, and that entire 1.4 line is lit up. When I do this part of the box, it lights it up too. Is it counting it twice? I don't know. It just may be the software's inability to distinguish the fact that the median falls somewhere in the middle of that, and part of them go left and part of them go right. So we'll leave the box plot as it is, and that's probably, I'm happy with that. If you chose standard deviation, that's not going to be wrong either. It's up to you to try and figure out, how do I represent where the middle is? What is the average magnitude of earthquake that happens in that area? I guess state of California for, what was it, 2012, I think it was. And you could say that, well, the median is on 1.4, and 1.4 seems to be the mode of this. So maybe 1.4 is a pretty good answer. So this would be your screenshot, and then you would comment about your findings. All right, so we move on to numero dos, which is, what is it? Science and the 24 cats. Yes. We go back to the 24 cats, and they had 24 cats, and they've already got you a graph set up here. They just haven't dragged any attributes. Now this one, they did. They compared what gender versus body length. So that's one that we're not going to do because they've already done it. Body length versus gender. And all of these questions here have to do with body length. And then they've got the background description of this. What each item means. All right, so we're not going to deal with length because that's been done. But we are going to, let's see, now we're going to do this. Switch to case card. All right, if we're not going to do body length, let's do weight, would be an interesting one. Weight versus age would be interesting. Let's do the weight here. And let's do the age here. And so you see the intersection of this. Now, one of the things that you could do here is that you could do the least squares line. That's the line of best fit for these dots. Now look at the R squared. R squared is 0.043, which means that this is a pretty crappy line. You would not want to trust it at all. I mean, it's there because it has to be, but and it even gives you a formula of you take 0.126 pounds per year times the age, and then add 10.3 pounds, and you get the value. I don't see that as being helpful at all. But the thing that we found is that there doesn't seem to be much of a relationship between age and weight, which is a little surprising. So maybe, and sometimes you get to the data and the data is no help whatsoever. Now I will say that your higher weights come with later age, and you have a cluster down here at a younger age and not quite weighing as much. So maybe you could make that distinction. But let's try something else. Let's try weight versus the sexes. Oh, I got to get a graph first. We're going to do weight. And I'm going to try doing the sexes in the middle. Now, another thing we could do is move it up here and do it that way. Now, there you're seeing that perhaps there is a slight tendency of the males to weigh more than the females. This is probably not terribly surprising for those that have lived around cats, as I have. Your males have a tendency to be bigger than the females as a rule. So this is not a terribly surprising statistic to me. And this, might be something that you could leave it right the way it is. Now, you could take this out and just have it like that. But sometimes it's more fun to have it by color like that. It just helps it stand out a little more. And sometimes the way that you present your visualization to the viewer is important. Not only did you work hard to gather this data together, but you want them to be able to appreciate the differences in what you have found. So graphics are important. So this would be something to where you could say, all right, by the weight, we can tell that there is a slight tendency for males to weigh more than females do. So that could be your statistical question. And the fact that you've got data, and although I will point out that so far, a lot of the data that we've looked at hasn't been overwhelming in any particular direction. I would not say that this result right here with the weight and the gender is not overwhelming. There is a slight tendency for males to weigh more, but I don't know that I would say that it's statistically obvious. Barely. So, and it may just be the data set that you're playing with. You only got 24 cats here. So the answer might be to going out and gathering data on more cats and trying to expand what you consider the population. Now, these are all cats living on the same block. If there is order to your population, then that's a different story. But if you just randomly got a set of 24 cats, and there's no purpose to them being a population, then you might reconsider the idea of what is are you trying to come up with your average cat here? Are you really going to narrow yourself to 24 cats, and where do they live? Because in some sense, are these feral cats? Do they live outdoors and hunt for themselves? Are they indoor cats, and do they have plenty of room to run? I've got two cats that when I got them, we were living in 1,600 square feet. And about 2 years ago, we moved into 600 square feet, which means that they have a lot less room to move around. And the boy cat has gained some weight, that is for sure. um, so there are other factors involved in this that, right now the data does not give us any sense of where the cats came from. So anyway, all right, we'll move on to the last one. I believe we have yet to do number 4, which is the planets. Which in my mind there are still 9 planets and not 8 of them, but that's just me. I think Pluto got the shaft, but in any case, and as far as not doing the same questions that they did, they just kind of did a general, what relationships can you find? Well, that's about as generic as you get. So anything is fair game. So we could, let's switch to the case card view. Whoops, I didn't want to do that. I don't know what I just did. I don't want to add a new attribute to this table. All right, anyway, I've got name, radius, orbit, day, length. All right, let's have some fun with that. The length of the day. Oh, there we go. There, that's what I wanted. All right, so we're getting a graph and we got our 8 dots. And so we're going to compare day length. Wow. That doesn't give us a lot to work with. So what if we compared it versus the orbit radius? That still doesn't give us a lot, unless we. And part of the issue is that you've got 6 of the planets down here, and then you've got Mercury, and then you've got Venus. Well, that's interesting. The 2 planets that are closer to the sun take longer to rotate. Now, this is the length of their day. Whereas everybody else has a day length of less, 1 day or less. But again, we're having problems playing with that. So let's do something else. Let's switch orbit radius down here and compare it to the radius. See if that does anything more interesting. And again, we have the larger planets out here, and then we have all the smaller planets down here. So we're going to run into a problem where you've got several planets that are small, and then you've got a couple of huge planets. And it's going to really, you talk about outliers. Let's do orbit radius versus year length. That might be an interesting comparison. Oh, now there's a trend. That is something where you could come in here and come in with a least squares line and look at that. Your R squared is 0.976. Now there's a relationship worth talking about. All right, is their orbit radius versus how long their year is, and there is a clear relationship. If you do 5.39 times their orbit radius and then subtract 8.8, you'll wind up with how long their year is. And that the R squared value tells you that this this is a good bet right here. So, and sometimes you just kind of have to monkey around with the data a little bit to find something that is worth talking about. Like I said, with the others, you had such a vast difference between the small planets and the large ones that it was kind of hard to talk about them on the same page, whereas here we have a clear relationship between all 8 of them that we can talk about. So I think I would go in this direction. Now, again, you know, that's not to say that this is the only thing that I expect to see on your worksheet. You know, there are other things that you could be looking at and trying to, you know, make some sense out of the data. So, but you know, that's because we've got like 8 or 10 different data items, categories here that we could look at. So I guess you know, clip and paste this one onto number 4, and then talk about the fact that you've got a nice clean equation. You know, if we were to find that they talk about planet 9, other than Pluto, that there's this planet out there somewhere that when they run the math on the orbit of the 8 planets and Pluto, um, their numbers are off unless they account for a 9th planet out there beyond the solar system that is also orbiting the sun, that is affecting the orbital radii of all the planets. And so they've been trying to figure out how to locate it, but it's so far out there that they can't really, you know, and the fact that it's so far from the sun, you know, what light is supposed to reflect off of it for you to be able to see it in the first place? So, you know, but this is something where they could begin to project, you know, if they knew what, you know, orbital radius, they could also tend to project how long its year would be, how long it would take to make one full cycle around the sun. And because I think gravity is going to have, this is probably the constant that's involved in this line, is that gravity is relatively consistent, you know, depending on how far you are from the sun. So anyway, all right, I guess I'll let this go and I'll shut up now.